Hello there. In this video, we're going to cover how to set slotted services in the CubePython package or using the CubePython package. So we'll just step through the source code here. First, we import the CubePython library, of course, and then we'll use the usual create network constructor for our network instance. And we'll put in an arrival distribution that is an exponential with rate of 5. And in this case, a deterministic service time distribution of 0.2. And then we put in for the number of services, instead of an integer or instead of a schedule as we've seen in the past, we'll put in this other class called slotted, which as the preview to the docstring suggests, it is an instance, or actually I should really say it's a subclass, it initializes an instance of the slotted schedule object. So how does this work, and what is the slotted scheduling approach for saying how many number of servers there are? Really, it's a little bit different from the number of servers being scheduled to say when they're on and off duty, is instead to say there are specific times, instance in time, where service is allowed to begin, but it's kind of like an appointment that you need to show up at the right time, otherwise the service doesn't happen. And if you are late for showing up, then you don't get to go into the service at that time. So the slots are really these, the idea there is there's specific moments in time where a specific number of customers can be supplied service that implicitly says something about how many servers are available under this model. And so we have these slot times that say the moments in time where service is allowed to begin, and the slot sizes is to say how many customers can be served simultaneously, basically how many servers. Okay, so usual setup for the simulation, we set a seed number just so we get consistent results. Simulation, you run the simulation for some amount of time, in this case 7 units of time. That should allow us to see the simulation running multiple times over. And we've got our records here, and then we can print the set of service start dates. And we'll just take a little peek at that. I'll create a terminal here. How to set slotted service times. So this is the set of times when service was allowed to begin. And you can see there's our 1.5, there's our 2.3, and there's our 2.8. But you'll also notice that there's a 4.3, and a 5.1, and a 5.6. So just like the server schedules that we've looked at in the past, it does roll over, it does cycle, it assumes periodicity. So if you want something that's aperiodic, you have to make sure that you set out and define these for a long enough period of time for the simulation that you're running. Otherwise, if it's some kind of regular scheduling thing, then this should just repeat the same behavior again and again. Now, for the slotted sizes, they'll also correspondingly be repeated exactly with the corresponding slot times. So hopefully that allows you to get certain kinds of structures simulated that are more characteristic of kind of rigidly scheduled appointment times. You have to show up at a specific time, or a certain thing has to be there at the right time, or a service doesn't happen. That's a key thing about slots, where with the server schedules that we've looked at before, there's intervals of time when some number of servers are on duty and therefore available for service, provided that they're not already busy providing service. The servers are really only available to start services, but can continue doing the service through intervals of time, but are only available at the start times defined in the slots. Hopefully that makes sense. Hopefully that's useful for your simulation problem, and I will see you in the next video. Have a great day.